Our next mini unit in calculus is on parametric equations. So our focus, to kind of give you a layout of what's going to happen over the next week, is this video is just going to be a basic introduction of what parametric equations are. Not a lot of calculus in this lesson, more a lot of just introduction and getting used to terminology and kind of how we work with parametric equations. Then we're going to focus the majority of our time on how we derive and use derivatives of parametric equations. And then the last part will be how do we integrate and what does the integration do for us when we do parametric. So that's kind of a layout of the coming week, and it shouldn't take more than a week to get through this. So parametric equations essentially have three variables. You have your x and your y, but both your x and your y are in terms of t. T is referred to as the parameter. Often it's written as t because it represents time of a parametric equation. So you're going to notice that parametric equations often are used to model things like movement and distance, and so that's why t comes in. So we can write a parametric equation as an x of t equation and a y of t. They always come in pairs. So you will have two equations that represent basically one scenario. So for example, if you look at this one right here, this would be a set of parametric equations that go together. So you have your x equation in terms of t and your y equation in terms of t. When you graph a set of parametric equations, it's all going to create one graph. You're not going to get multiple graphs here. And the graph is going to be created when you put t values in into your x and your y to get coordinates. And when you put all of that together in your interval, we call it the interval, the parametric equation is called a planar curve. And oftentimes they use the letter C to represent a planar curve. So we're going to start by just showing you on your calculator where parametric mode is, just so you're familiar with it. So if you go to your calculator, you don't use the calculator a ton recently, but this will help you show one piece. If you go to the mode button, you will notice that right now you may or may not have an imaginary mode, but what you'll notice, the fourth thing down says FUNC, function mode. That's your normal default mode. You can actually switch to parametric mode, which is the PAR. You can also switch to polar, which is the next one, and we're going to do that probably right after winter break. But if you switch it to parametric mode and you go to y equals, you're going to notice now that when you enter in equations, you're going to enter them in as an x sub 1 and a y sub 1. Those will go together. So for example, if I wanted to enter in this t squared minus 4, also notice that it'll automatically switch to the parameter t for your x and then your t over 2 for your y. Now, when you graph, if you go to your window, you're going to be given different t values. Oftentimes, they go like a unit circle, like they go from 0 to 2 pi, and then have your x value and your y value. So I'm going to show you what it looks like on this graph. You're not going to see a whole heck of a lot, but I want to show you how you actually get it to be done by hand, kind of like where this comes from. So when you're asked to sketch, and you will not be asked to sketch much, this is just kind of giving you some background information. If you're asked to sketch something that is in parametric form, you're going to plot your points in order of increasing values of t. So the order that you plot actually makes a difference. So for example, with this one, if I'm going to make like a little table here, and I'm going to make, let's see here. I'm going to put in my t value, and I'm going to get an x and a y from that. So I'm going to kind of create, usually we have like an xy table. Well, now I have a txy table. And I'm going to put t values in that go from -2 to 3. I'm going to go just whole number increments there. So when I put -2 into my x equation, -2 squared is 4, minus 4 is 0. And when I put -2 into my y equation, I get -2 divided by 2, which is -1. So that's going to be the first point on my graph here. So I'm going to go to 0, -1, and I'm going to put a point. I'm going to do it like this. Put a point like that. Then I'm going to put -1 in. So -1 squared is 1, minus 4 is -3. And then I'm going to put -1 in for t, -1/2. So now this point is at -3, -1/2. So I'm going to put a point right there. I'm going to do another one. I'm going to start connecting the dots. When I put 0 in, I get -4 for my x, and I get 0 for my y. So -4, 0 is here. So as I start to connect the dots and I draw, the direction that I draw is referred to as the orientation, and you're actually going to put little arrowheads on it. It doesn't like me doing that. And that's going to kind of show the direction of what's happening as we put in bigger t's. So let me do another one here. So when I put 1 in, I'm going to get -3 and then 1/2. So that point is going to be -3 right there. And then I'm going to put 2 in, and I'm going to get 0, 1. So 0, 1 is going to be here. Put it in black so you can see it. And then I'm going to put 3 in. 3 squared is 9, -4 is 5, and then 3 halves. So I'm going to go to 5, 1, 2, 3, 4, 5, 3 halves. And when I connect this, I'm going to draw those little arrowheads. That is referred to as the orientation of the curve. So you actually have a curve that kind of has movement with it. As the t value, as the parameter gets larger, I create these next points. So you do have to sketch in an order that keeps kind of shows you as t gets bigger, what direction is the graph moving. And that is, again, called the orientation of the graph. Now, you can change your parameter and still get the same graph. For example, if I were to graph this, I did from -2 to 3. I could also graph it from -1 to 3 halves, and I would get the same graph, but it would be traced more rapidly. So you would actually have the same picture, but the speed would speed up. The speed would be faster. So we can also use this idea to show speed. So if you go to your calculator, if I want to change my window, so I went from -2 to 3. So there's that piece. If I went from my window, if I went from -1 to 3 halves, you get part of it. You don't get the whole thing. We actually have to go a little bit farther to get that. But you get that same piece, but it traces a little quicker. So we have this ability to use our calculator. I will be honest, I don't use the calculator much to graph them, but I wanted you to see where these points come from. So you have your x and your y that both get t plugged in to figure out your coordinates as you graph, and it does have this orientation. So what you're going to be asked to do is you're going to be asked to do something called eliminating the parameter, which is going from parametric form to Cartesian form. So we're going to go parametric form. It's one of the few things in this intro that you could actually be asked to do on an AP test, is to go from parametric form to Cartesian form. Cartesian form is truly just like x's and y's, what we're used to. So you would have something like the parametric equations we just had. So t squared minus 4 and t over 2. I'm just going to keep using that example. If you're asked to eliminate the parameter, what you're going to do is basically you're going to do a substitution. So you're going to pick one of these two equations that you're going to solve for t. I think the y equation is simpler, so I'm going to solve that for t and say, well, t equals 2y. And then you're going to replace that into your x equation. So you're going to replace it with 2y here, squared minus 4, which is going to be 4y squared minus 4. Now, the difference with Cartesian form is you lose that direction. You don't have that orientation that you have, but you can find something that will give you the same shape graph. So if it's something like this where you have x's in terms of t's and y's in terms of t's, pick the one that is simpler, solve for t, and then do a substitution into the other one, and you can get it from parametric form to Cartesian form. If it's trig based, so I've seen one that looked like this before where you have x is cosine, and a lot of times with trig, instead of using t for the parameter, they'll use theta. So theta is just your parameter, your t. So if I have that x is, well, I'm going to make it 3 cosine theta, and I'm going to make y equal to 4 sine theta. So this is another example of parametric equations just written in terms of theta instead of t's. If I want to rewrite that as Cartesian, I actually need to get cosine and sine I need to isolate the cosine and the sine. So cosine would be equivalent to x over 3, and sine of theta would be equivalent to y over 4. And then the way I work with this is I go into my Pythagorean identity, which is sine squared plus cosine squared equals 1, our most basic Pythagorean identity. So then I can substitute into that identity my x values and my y values for sine and cosine. So I would have y over 4 squared, that would be plugged in for sine squared, plus x over 3 squared equals 1. And if I want, I could simplify it to y squared over 16 plus x squared over 9 equals 1. So that gives me the ability to rewrite and write it in terms of x's and y's instead of a parameter of theta. I also saw one time that looked like this. So x equals 5 plus 2 sine theta, and y equals 3 minus cosine theta. And the same thing, the directions would say eliminate the parameter, get it in terms of a Cartesian form. So we're going to rewrite sine. So sine, I'm going to do a little bit in my head here. I'm going to subtract 5 and divide by 2. So I get x minus 5 over 2 is what sine of theta is equal to. And then cosine, if I add cosine to the other side and then subtract y, I get 3 minus y. So again, I can go into that Pythagorean identity, the sine squared plus cosine squared equals 1, but I'm going to write it, I'm not going to do a lot of algebra simplifying here, I'm going to leave it squared, so I'm going to write it as x minus 5 over 2 all being squared plus 3 minus y all being squared equals 1. So anytime I'm trying to get it back to Cartesian, if it's trig-based, we're going to focus on Pythagorean identity. If it's not trig-based, if it's just written as something that looks almost like a linear form or quadratic form, I'm going to solve and substitute. So there was a question, it might take me 1 second to find it. This was a question that was asking kind of the same idea. So it gives you a parametric curve. It says the parametric curve is x equals natural log of t and y equals 4t plus 1. And it wants you to write the Cartesian equivalent to it. So the Cartesian of the curve. So that's what they're going to ask you to do. They're not going to ask you to do a lot of like high level graphing at all. So with this one, make this so I can write on it. I am going to... I'm actually going to solve for t in the x equation. If I take base e on both sides, so if I exponentiate both sides, I get t equal to e to the x power. So now I can take that and put it where the t is. So my y equation would be 4e to the x power plus 1. So my answer is D. So that's an example of one that was on an AP test. This was several years back, but it was not asking you to do much other than rewrite, which is one of the only like intro topics that they'll ever ask you to do. I've got one more. This one wanted to know that what would this curve look like? And this is one where if you don't have a calculator, then you have to kind of be reliant on switching it to Cartesian form. So for this one, I'm going to solve the x equation for t squared. So I'm going to say that t squared is equal to x minus 3. And then I'm going to put that right here. So I'm going to have y equals x minus 3 plus 4. So I have y equal to x plus 1, which when you look at this, you end up with something that is just a line. It's not a circle because it's just an x. It's not a parabola because it's just an x. It's not an ellipse. It's not a hyperbola. All of those things have very funky formulas. What you'll have with this one is you just have a single x and a single y. You don't have any exponents. You don't have anything that's rational. So you can make that substitution and say, well, this is definitely a line. So those are the types of questions that you could be asked. Very simplistic, mainly focusing on eliminating the parameter, whether it's written in a trig form or in more of like a linear function-based form. And that's also how you get the calculator into parametric mode to graph. I truly don't use the calculator a ton to graph, but it does give you that opportunity to do that as well. And that's the basics of parametric functions. We're going to start deriving them and integrating them in the next couple of days, but at least now you know what they are and some of the terminology that we use.